What's up, guys? Today we're going to talk about what is a loop. Loops are really a way to repeat steps without having to write every single line over and over and over again. So because you don't have to do all that writing, it also reduces syntax errors, and most importantly, it reduces the amount of time you spend writing the actual code. There are different kinds of loops, and depending on what language you're using, depends on what type of loops are available. Today we're just going to look at a little bit on the while loop and the for loop. Now, in any kind of loop, an execution is always based on a condition. So while x is less than 3, this is your condition, x being less than 3. If that's true, if x is less than 3, then the program would print I love programming. If it's false and x is not less than 3, then it would totally skip that statement and not run that statement at all. To make things even more complicated, you can have a loop inside of a loop. If we look at while x is less than 3, if x was 2, for example, it would be true. Then it would print I love programming, and only x less than 3 is true would this while even be checked to see if it was true or not. If it's true and it prints I love programming, then it will check this while k is less than p. If that's also true, it will then print programming is hard work. Now, the trick to a loop being inside another loop is if k less than p is true, this inner loop will print programming is hard until the k is equal to p or greater than p, and then the program's going to jump back up and check the first while, and it could even run again if k is again less than p, and it goes through it again, and it could even rotate again. So we always have to stay within the loop that we are in as long as that condition is true. Now let's look at that a little bit closer. If we have some loop practice here, the first type of loop I showed you, let's say k is equal to 4 and f is equal to 1. While f is less than k, let's print I love programming, and then we'll say f is going to be equal to f plus k. We can look at a for loop, and depending on the language used, the for loop will look differently. However, this is one example or one type of a for loop. It's just written differently, but it often can do the same thing. We use while loops most commonly, but sometimes a for loop can easily move up and down a list or a collection or an array, and it's just easier to use a for loop in that condition. So we look at this for loop, and k is equal to 4. So we say for int f equal to 1, f less than k, f equal f plus k, print I love programming. But interestingly enough, the way that the for loop works is first we initialize k to the value of 4. Then we look at the for loop and we say int f equal 1. This is initializing your f equal to 1, putting that value in there. Then we check to see if f is less than k, and it is. 1 is less than 4. It's true. So we actually jump down outside of these parentheses, and then we print I love programming, and then we jump right back up here, and then we do f equal f plus k. So the for loop jumps around just a little bit more. But let's look at this loop practice in a program called Raptor. This program is pretty cool. My only issue is that the loop section is backwards. I'll show you that, and we'll deal with that. The cool part of Raptor is it helps you to make sure that your logic is correct in your programming. If you don't know how your loops are going to produce output or whatever it is that they're going to do, then you can't write loops properly. The same way for your whole program. You have to understand how the program is going to run in sequence so that you can put that in the proper order. So let's take this assignment here, and we will set k equal to 4. It'll make you save it. Double click the box and set K equal to 4. I'm going to do another assignment here, and I'm going to set F equal to 1. And then I'm going to drag my loop. And this is what I was talking about. Usually if it's true, then it loops again. And this is just a little bit backwards here, but that's okay. We can work with that. I'm going to double click the diamond, and I'm going to say, if I want it to be false actually, so it can run, I'm going to do it backwards. So let's say F is larger than K. So if F is larger than K, then it will loop again. And I'm going to drag this output here, and I'm going to put in I love programming. Remember, we always have to put anything that prints to the screen in quotes. And then I need to put in an F equal F plus K. So I'm going to grab this assignment, double click it. I'm going to set F equal to F plus K. Done. Now let's run it and see what happens. As you can see, it put those values in. It went through and it said, I love programming. And then it added that together. Then it became false, so the run was complete. Let's slow this down just a little bit so you can see exactly how this goes. Here's the slowdown. Start. It sets K equal to 4. It sets F equal to 1. It checks to see if F is larger than K. It should not be. It prints, I love programming. There's the new one. And then it adds to the F, and it goes right back up to the top of the loop. And then it checks this value again. It is false. So it follows down this side, and then it ends the program. Everything in a loop is based on the condition and whether that condition is true or whether that condition is false. Now let's look at this inner loop practice. As you can see, I have K is equal to 4, F is equal to 1, while K is less, or while F is less than K, print I love programming. Then we're going to add F and K together. Then we have an inner loop. If K is greater than F, print programming is hard. So let's take this original programming that I have, and I'm going to add a loop inside this loop. So I'm going to grab the loop down here and put it right underneath here. I'm going to double click it. We have to remember that we're a little backwards. So while F is greater than K, and then we're going to get an output here that says programming is hard. There. Now, I'm going to clear the stage here, and let's see how this runs. Okay. So it says, I love programming, because this loop never even ran, because F is now larger than K. And you can see that when we run it slow, if F is larger than K, and F is larger than K, it's going to go yes. And then it's just going to go back up and it's going to check this loop. F larger than K, and it is yes, so it goes right down to the end. Now, if I took this statement right here out, where F would be no longer larger than K, then this would run. And here's the thing, if I don't ever add and it stays the same, this will run forever and ever and ever, and then you're going to have this never-ending loop. Let's check that out. If I can get it selected. And then delete it. And now let's run it and see what happens. You see, it just keeps going and going and going and going. Because what happens with loops is there has to be some sort of method escape. And that's exactly why we have these conditions to look at every single time. If we look at a condition, that tells us whether or not, I'm going to stop it, look at that. That tells us whether or not that program is going to run. So this is why we use a condition. This is why we use any kind of escape sequence. So if we ask a user, maybe put in Q for quit whenever you're ready to complete the program. However we do it, we have to find a way to make sure that the program ends, or we can end up with a never-ending loop. You don't want a never-ending loop unless that's exactly what you want, right? So if you're creating a demo that's going to run in a store, it's going to never-ending loop through the demo. That's fine. In general, we don't normally have our loops that run forever. They need to find a way to stop. And if they don't stop, what can happen is the server can actually crash, and then users won't be able to complete their work. Okay? So as you can see, loops can be confusing. It is very important to step through each loop. Make sure you understand exactly what that loop is doing, how that practice is coming out, and what's going on. Thank you all for joining. I hope this really helps you with learning loops. Have a wonderful day.